In a bold declaration, researchers assert they've uncovered a new planet that defies all known concepts. NASA, famed for its revolutionary discoveries, has disclosed that this planet is remarkable not only due to its size and position, but also because it emitted light that seemed to be artificial. Could this be the beginning of unraveling mysteries that could radically alter our understanding of the cosmos? Is this discovery pointing to the possibility of extraterrestrial life? By delving into NASA's incredible revelations, we might soon discover the truth behind these unusual lights. In 2007, NASA launched the Dawn spacecraft with the goal of investigating some of the most captivating objects in our solar system. Armed with 3 ion propulsion engines, Dawn embarked on a journey that began with a 14-month mission to study Vesta, the second-largest asteroid in the belt. Dawn sent back high-resolution images and data, which unveiled Vesta's intricate surface and diverse geological past. After completing its mission at Vesta, Dawn moved on to the second and potentially more thrilling phase of its mission, a close examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to break free from Vesta's orbit and journey toward Ceres, a feat that traditional chemical propulsion systems wouldn't have permitted. These engines provided a gentle, constant thrust, allowing Dawn to travel vast distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt, positioned between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in the solar system until it was reclassified in 2006. With a diameter of about 9,950 kilometers, Ceres is the most massive and largest body in the asteroid belt and one of the most intriguing due to its unique features. Scientists eagerly awaited the first close-up images of this mysterious world, which revealed bright spots scattered across its surface, particularly within a large crater known as a crater. This bright spot immediately piqued the interest of scientists and sparked significant speculation within the scientific community. Before dawn, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. There was little known about this dwarf planet, and the prospect of obtaining high-quality, close-up images promised exciting new discoveries. The Dawn mission aimed to deepen our understanding of the formation of the solar system and the role of water in the development of planetary bodies. The bright spots on Ceres, which have been seen on other asteroids as well, could be made of highly reflective substances, perhaps salts left behind by evaporating water. This finding suggested the possibility of cryovolcanism on Ceres, a process where volcanoes erupt water or brine instead of molten rock. But what exactly are these mysterious lights, and what do they reveal about Ceres' nature? Could they be evidence of ongoing geological activity or something even more extraordinary? Ceres is distinct from other bodies in the asteroid belt due to its size, mass, composition, and potential for containing water and ice. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, indicating that it could provide further insights into the early solar system. After 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking an important milestone as it prepared to deliver the first close-up views of the largest object in the asteroid belt. As dawn neared, the images of Ceres became clearer and more detailed, revealing a world that had long been a mystery. The first images showed a surface with numerous craters, indicative of a long history of impacts. What captured the attention of both scientists and space enthusiasts were the enigmatic bright spots scattered across the rocky terrain. As the resolution of the images improved, the scientific community began to hypothesize about the nature of these spots. Were they patches of ice reflecting sunlight, or could they be something even more unusual? Theories ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's surprise, closer inspection revealed that the brightest spots were not a singular entity, but a cluster of several distinct spots. The most widely accepted explanation is that these are salt deposits left behind by the sublimation of water. This suggested that Ceres may have, or still has, some form of geological activity capable of bringing water or brine to the surface, where it rapidly evaporates, leaving behind reflective salt residues. These findings challenge previous assumptions about Ceres, presenting it as a much more dynamic and complex world than originally thought. The potential existence of underground water or brine pockets raises profound implications for the possibility of life within our solar system. Ceres is a fascinating dwarf planet, often described as an icy world with a rocky but porous surface. Unlike most asteroids, which are made mostly of rocks and metals, Ceres stands out due to its unique composition. Its surface is a mixture of water ice and hydrated minerals, including clays and carbonates, which makes it less dense than its rocky neighbors. This composition suggests that Ceres contains a significant amount of water. Its surface is rocky but porous, with ice and other volatiles trapped within, making it more like a comet than a traditional asteroid. The dwarf planet is thought to have a distinct interior, made up of a mantle and a core rich in water ice, which accounts for roughly 50% of Ceres' total volume. Ceres' mantle is likely a mix of rock and brine, encasing a core that could consist of denser materials such as silicates. The presence of a large amount of water ice suggests that Ceres might have hosted liquid water in the past, especially if its core was heated by radioactive decay during its early history. This internal structure distinguishes Ceres from other neighboring asteroids and raises fascinating questions about its potential for geological activity and the role of water in its evolution. But that's not all. The discovery of ammonia clays on Ceres suggests that this dwarf planet may have formed in a cooler region of the solar system and later migrated inward. The presence of ammonia may lower the freezing point of water, which supports the idea that surface brines could exist. These insights into the composition and history of Ceres not only enhance our understanding of this captivating world, but also provide important clues about the processes shaping and evolving icy bodies across the solar system. Cryovolcanism is a fascinating and relatively rare geological phenomenon, particularly when compared to the more familiar volcanic activity we observe on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, expel materials such as water, ammonia, or methane. These substances can exist as liquids or gases in extremely cold environments. Cryovolcanoes on Ceres function by allowing water mixed with dissolved salts to reach the surface. When the salty water comes into contact with the vacuum of space, it rapidly sublimates, transitioning directly from solid or liquid to gas. This process leaves behind glowing, reflective salt deposits, which form the bright spots observed on Ceres' surface. The most famous of these bright spots is located in a crater called a crater, known as Spot 5. This area has attracted significant attention due to its high reflectivity and periodic changes observed by the Dawn spacecraft. These changes are believed to be caused by water sublimation, suggesting that cryovolcanic activity may still be occurring or may have occurred recently on Ceres. In addition to Spot 5, Ceres contains several other bright spots, each with distinct features. These spots are scattered across the surface of the dwarf planet, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots underscores the dynamic and active nature of Ceres, challenging previous assumptions that it was a geologically inert world. As the Dawn spacecraft captured more detailed images of Ceres, a wide array of surface features began to emerge. Ceres' surface is dotted with craters, each telling the story of the dwarf planet's history. As more data came in, scientists started analyzing the patterns and characteristics of these bright spots, leading to groundbreaking conclusions about the planet's active surface processes. Ceres is now considered a complex, dynamic world rather than the inactive body it was once thought to be. The discovery of such bright spots spread across different regions further suggests that Ceres may be experiencing ongoing geological transformations, with potential implications for its future and for the broader understanding of icy celestial bodies. The craters that cover Ceres' surface, in addition to the bright spots, reveal much about the planet's tumultuous past. These impact craters serve as a historical record, shedding light on the events that have shaped Ceres' surface over millions of years. As Dawn sent back more detailed images, scientists were able to identify an astonishing variety of surface features that were previously hidden. Each of these craters tells a different story, offering valuable insights into Ceres' geological history and evolution. The mission to explore Ceres and its unique features continues to inspire interest among scientists and the general public alike. It's not just about the specific bright spots or craters. This mission has opened new doors to understanding the wider dynamics of the solar system. While some questions remain unanswered, the discovery of potential cryovolcanic activity has made it clear that Ceres is far more active than initially assumed. The evidence of water, brine, and possibly even the potential for life provides exciting prospects for future exploration. Many experts now believe that the ongoing study of Ceres will eventually lead to even more profound revelations about its history, its potential for life, and the forces at play beneath its surface. This exploration is essential in expanding our knowledge of other celestial bodies, especially those that, like Ceres, could harbor the necessary ingredients for life. In the years ahead, scientists will likely focus on further investigations into Ceres' cryovolcanism, its subsurface, and its ability to sustain water or brine. As we continue to study the outer reaches of our solar system, missions like the Dawn spacecraft will remain central in unlocking the mysteries of distant worlds. The exploration of Ceres and other similar bodies provides a glimpse into the diversity of planets and moons that may hold the answers to some of the universe's biggest questions. For now, the mystery of the bright spots on Ceres is just one more clue in the puzzle of our solar system's evolution, leaving scientists and explorers eager to understand more about the potential for life beyond Earth. If this mission has proven anything, it's that there's still so much we don't know about the planets, moons, and asteroids that surround us. Ceres' potential for harboring water and its unique geological features show that even the most unlikely places could one day be vital to understanding life elsewhere in the universe. The ongoing discoveries from NASA's Dawn mission will continue to shape our view of the cosmos and drive future exploration into the unknown. Who knows what other surprises await us in the depths of space? Only time will tell, but the search for answers continues. As the Dawn spacecraft journeyed closer to Ceres, new revelations about the dwarf planet began to unfold. The bright spots that sparked early excitement in the scientific community were not just intriguing anomalies. They hinted at a deeper, more complex story unfolding on Ceres' surface. Scientists had previously speculated about the possibility of water or brine existing on this distant world, but the discoveries made by Dawn confirmed that these ideas were worth further exploration. The presence of salts and the reflections of light from these spots suggested that Ceres might still harbor traces of water beneath its surface, possibly within pockets of ice or brine. The potential of cryovolcanism on Ceres opened up a wealth of possibilities for understanding the geological activity on other icy bodies in the solar system. Cryovolcanic activity, as opposed to traditional volcanic eruptions, involves the eruption of water, ammonia, or other volatile substances instead of molten rock. This phenomenon has already been observed on moons like Enceladus and Europa, where geysers of water are released into space, but Ceres presented a new frontier. The evidence of similar activity on Ceres, in the form of water sublimation and salt deposits, showed that this process might be more widespread throughout the solar system than previously thought. What made Ceres even more intriguing was that its composition suggested that it could be much more than just an asteroid or a typical dwarf planet. Unlike other rocky bodies, Ceres has a unique mix of water ice, hydrated minerals, and other volatile compounds. This unusual combination has made Ceres an object of increasing interest for scientists who are studying the origins of the solar system. The fact that Ceres contains so much water, in the form of ice and brine, further complicates our understanding of the role water plays in the evolution of celestial bodies. Could Ceres have once been a more habitable world? Could its subsurface still host liquid water, making it a potential candidate for life? NASA's Dawn mission brought us closer to answering these questions, and the data it collected will likely fuel scientific research for years to come. As more images and analyses of Ceres' surface were sent back to Earth, new features began to emerge that were previously unseen. The surface of Ceres was revealed to be much more varied and complex than scientists initially thought. The diversity of craters, cracks, and surface features painted a picture of a world shaped by countless impacts and forces over millions of years. Some of the craters, in particular, held clues about Ceres' internal composition and its potential for active geology. The depth and size of these craters suggested that Ceres had experienced significant collisions in its distant past, shaping the way its surface looks today.